In this video module, we'll be discussing Boolean arrays and masks and giving some examples using NumPy. So first of all, the work that I'm going to do, or the demonstration I'm going to give, is based on this Jupyter notebook from the Python Data Science Handbook. And so I'm going to use that directly, so you should have a copy of that if you're going to follow along. So when we talk about a Boolean mask, basically we start out with some array. We then apply some condition, and then we generate something called a mask, or that is a Boolean array. So as an example, let's think about this array, just an array of integers is my array, and then I apply this condition, and my condition is less than 5. The resulting Boolean array would be the same shape as the input array, and it would just be a element by element application of the condition. So in this case, 8 is less than 5, so that's false. 2 is less than 5, so that's true. 1 is less than 5, true. 6 is not less than 5, false, and so on. So what we do is we take some arbitrary array, apply some condition, and generate this mask. Also note that we sometimes represent the mask as 0, 1, so a simple transformation of false represents 0, and 1 represents true. And so what we hope to answer in the video module, or at least to demonstrate, is one, how do we do this? So how do we generate these Boolean arrays or masks given an array and a condition? And two, well, how do we use them? Why are these useful? And so to do that, we are going to use, as I said, the Jupyter notebook. And the one that we're going to use is comparisons, mask, and Boolean logic. Again, this is freely available from the GitHub account right here. You can see the address here. And so I'm going to, again, use this without modification. We're going to do some work on it, but I haven't done anything else to it other than what you get if you just download from the website. So also note that I'm not planning to read this Jupyter notebook to you. Instead, I'm just going to hit the high points and discuss some of the issues, but I recommend that you thoroughly read the whole notebook and make sure that you understand all of the examples. And again, my plan here is to just hit the high points. Okay, so here's what we're going to do. The example, he starts with a basic example, counting rainy days, and using a data set from the Seattle 2014 climate values, and he uses pandas to extract the precipitation values. And so what you end up with when you read the data file and then you grab just one of the series from the pandas array, from the pandas data frame, is a NumPy array called inches. And you can see that we report the shape as 365, a single dimension array. And so what the array contains is the rainfall values from January 1st to December 31st, 2014. So 365 days in a year. So inches 0 would be January 1st, inches 1 would be January 2nd, and so on. And the values that you have are the rainfall values from Seattle. So the first step that they did was plot these to just get a view of the data. So just use matplotlib, did a histogram, and then specified the number of bins to use. So you can see that. You can see the histogram values of the rainfall. The question is that this is useful, but it doesn't really do a good job of conveying some of the things that we'd like to see. The two examples that he gives here, how many rainy days were there in a year, which you could sort of get if you eliminated the 0 and you counted these, but there's no convenient way to count them. You can get an impact, but you can't get those actual values. Secondly is, well, what if we wanted the average participation on those rainy days? Or how many days are there more than half an inch of rain? So it's sort of general diving into questions that you'd like to have answered that just don't fall out naturally from this view. So the basic approach that he mentions here, that he calls the manual approach, or by hand, questions by hand, would be looping through the data. So in essence, if you wanted to answer the question of how many rainy days were there, we could simply loop through the inches array and count the number of non-zero values, and that would give us that value. If you wanted to know the average precipitation on rainy days, then you would simply create a subarray or create a sublist and extract those values that were non-zero, and then calculate the mean and so on. So that's a standard way of doing this type of analysis. What we're going to do instead is we're going to look at how we can apply Boolean arrays and Boolean masks to simplify this process using NumPy. So the first thing we look at is this comparison operators as ufuncs. And what we've looked at previously, both in class and if you follow through the textbook examples, they focused on using ufuncs using arithmetic operations. So you have plus, minus, and so on. And it leads to an element by element arithmetic operation is what we looked at before. But NumPy also implements comparison operators such as less than or greater than or equal to in an element by element fashion. And so if you look at the example we have here is we define a NumPy array 1, 2, 3, 4, 5, and then we simply apply the less than 3 operator and say x less than 3, and the resulting value is an array that's the same size as our input array, and the element by element application of the condition. So it's saying is 1 less than 3? Yes. Is 2 less than 3? Yes. Is 3 less than 3? No. Is 4 less than 3? No. Is 5 less than 3? So if you go back to our Boolean mask definition, that's exactly what we're generating is we're taking this input array, in our case 1, 2, 3, 4, 5, and then we have this condition of less than, what was our condition? Less than 3, and then we apply that and the resulting value is the Boolean mask. So I'm going to skip all of these other examples where we're just applying other conditions such as greater than or less than or equal to. You should definitely go back and take a look at those or make sure that you understand those and experiment with those a little bit, but I don't think I need to go through that. But the one I do want to jump down to is the one here where we're actually comparing, we're doing the vector arithmetic here and comparing two arrays. And so if you look at what's happening here, before I show that, let me just jump in and insert a cell below and let's look at these individual components of our statement here. So if we just do 2 times x, what we're doing is we're multiplying the array by 2, and so the result of this expression is this array 2, 4, 6, 8, 10. Similarly, if we apply the x squared, then the result is also an array of 1, 4, 9, 6, 12. And so what the comparison is actually between the two arrays. And we can see that if we compare those, only the element 4, so 2 squared is 4 and 2 times 2 is also 4. And so you can see in this case we've applied we've generated a Boolean mask based on 2 separate arrays, based on a comparison between the two arrays. So as before, this also works in the case of multidimensional arrays. And so in this case, we generate an array that is 3 by 4. And in this case, we just use random integers between 0 and 10. And we can apply the same array condition here. In this case, we're just applying 0 to 6. X is less than 6. And so the result here is that we have an array, we have a condition, and we generate the mask which applies the condition element by element. So just like we saw before, except in this case we have a multi-dimensional array. Okay, so the question is, well, how do we work with these? So now that we have these Boolean arrays, how do we use them? What do we use them for? And so here's an example, a couple of examples before we get back to our rainfall example. One is we're just going to show x here. So there's my oops, I didn't execute this one, so let me go back and execute this. So I get my x is less than 6, and then print the values. And now we have our 3 by 4 array. And so suppose we wanted to know how many values are less than 6. Well, we can simply use the count non-zero function with our Boolean mask. So here's our Boolean mask of x is less than 6, which we know what generates, right? It generates this true-false array that's 3 by 4, and it just counts those non-zero values, in this case 8. We can also use the sum value because, as I said, the x is less than 6, we know generates this array. And so if I just do a comparison saying less than 6, the true values are going to equate to 1. So a true value is equal to 1 and a false value is equal to 0. So if I just use the summation, I get the same value of 8. And as he points out, the benefit of using the sum in this case is that I can apply the axis function. And so if I use, the axis parameter. And so if I do that, then I'm applying this, or I'm counting the number on each row. So the resulting value is 422, and so that tells me there are 4 values on this row that are less than 6, 2 values on this one, and 2 on this one. So it's really nice to be able to apply that sum across the axis. There are several other examples here you should look for, all and any. I'm going to skip all those and let you have a look at those. But what I do want to demonstrate, I want to skip ahead to this Boolean operators discussion, and now he switches back to our rainfall data. Recall inches was an array, 365 elements for the rainfall in Seattle. And so this example says what I'm going to do is I'm going to take inches greater than 0.5, and so I'm masking this to pull out or to have the true false values for those days that had rainfall of greater than 0.5, and I'm then creating a second one for inches less than 1. So if we just look at those individually, and say inches, let's see, inches greater than 0.5, and execute that. There's our array of days where we had more than a half an inch of rain. And then the second one, these are the days where we had less than 1 inch of rain. And so I'm applying this AND condition between two separate Boolean masks or two separate Boolean arrays. And so the resulting value simply counts, or well, actually I sum those. And so the resulting expression on the inside of my sum is going to be this element by element comparison of this Boolean array and this Boolean array. So which in fact would be another Boolean array illustrating where both conditions were true. So let me get rid of this cell, and now we see how we can extract information that we want from our data directly. And so you jump down here again, you should read the previous cells, make sure you understand, and see that we have some summary data that use those types of masking operations. So if we want to know the number of days without rain, we simply apply the inches equals 0. If we want to know the days with rain, we say not 0. If we want more than 1.5, we've already seen that. If we want if we want rainy days with less than 0.2 inches, then again we have two conditions: that it's raining, in other words inches greater than 0, and inches less than 0.2. And so you can see, using this technique, we can easily aggregate across the different conditions to query the data set for particular information. So finally, we will look at how we apply these Boolean arrays as masks. So I've been calling them masks, but we haven't really done the masking operation yet. So let's have a look here. So we have x here. Let's see, make sure I haven't changed x. No, that's still our random values. And we already had this condition that we saw before. So we have x is less than 5, and we can just apply that, and we get our Boolean array. And so the question is, if we want to, or the issue here is to apply the mask, is if we want to select the values from the array. So not only do I want to know the true false values, I want those specific values that are less than 5. That is the actual masking operation. So we do that by simply taking the mask, the x is less than 5, we know generates this array, and then using this as an index into the array. And so we hit x less than 5, and we end up with the array 0, 3, 3, 3, 2, 4. In fact, all of the values from our original array that meet the conditions specified to generate our Boolean masks. So in this case, we took an array and a condition, and then we extracted the values from the array that met the condition. So we're not, in this case, interested so much in the mask, but we're interested in those specific values. So we can apply that in our data set to get even more interesting values. So for example, I'm going to create a mask that's just inches greater than 0, and I'm going to call that rainy days. So let's take a look at that. If we do that, oops, I've already got rainy and summer here, so let me get rid of that and redo that. That's what you would see from the original downloaded version. If we just look at these values and I say, well, what is rainy? Oops, rainy. And execute, again, what we see is this is simply a Boolean mask that I've named so that I can use a little bit later on for other analysis. So similarly, if I look at days, I've just got a vector of 365 days. So this is just a vector of numbers, 0 to 364. And so the second thing I'm going to do is create another mask that says, okay, I'm going to just pull out the summer days. So we mentioned here somewhere how they define summer. I saw it somewhere. I don't remember where it is, but the summer days are greater than day 172 and less than day 262. And so if we run that and just look at summer, I could type, it would help. Summer, you can see that we took our days array, 365, and said, pull out the ones that are greater than 172. That's one matrix or one Boolean mask. Then pull out the ones that are less than 262. That's another. And then do an element by element and. And so you can just look and say, okay, right here in the middle, here are all the trues. So these are all of the summer days. So now I have two interesting masks. I have the rainy days and I have the summer days. And with those, I can do a lot of interesting analysis. So for example, the ones that they did, let's execute this one, and we're saying, okay, I'm going to print the median precipitation on rainy days. I'm going to take inches and apply the rainy mask. And so as we saw before, when we have a mask that we apply or we use as an index into an array, it just pulls those true values out. And so the resulting array, the resulting one vector array, is going to be all of the days that were rainy, and we can just compute the median. Similarly, if I want to know the precipitation on summer days, I can use the summer mask. If I want to know the maximum precipitation on the summer days, and so on. So by applying these, by defining the rainy days and then defining the summer days, I can mask the precipitation data for those specific conditions. Also note we have the second one here that's rainy and not summer, and so this would be the median precipitation on non-summer days. That's the non-summer here that we get. And so if we just investigate that one a little further, look at that and say, suppose I just want to see what this looks like, and so I just say not summer, and then have a look, and it is in fact the exact opposite of what we saw when we looked at the summer data. So you true here in the winter, false here in the summer, true back in the fall. And so we can use the variety of Boolean operators to manipulate our masks to get what we are really interested in. And so back to our slides, if I can, right there. What we've looked at is this notion of Boolean masks, and we looked at how to create them and then how to use them to simplify the analysis of the data.